P5 Part C notes cover adding and subtracting rational expressions. So it's a lot to do with what we've been doing. There's still the factoring and stuff like that involved, except now instead of multiplying and dividing, we're adding and subtracting these fractions, okay? So the general idea is that they have to have the same denominator, just like adding and subtracting any kind of numeric fraction. I can't add 1/2 and 1/3 without changing the denominator to be the same, right? Same concept, except now we're going to have expressions in the bottom. So whatever's in the bottom has to be the same. If it's not, we're going to find the least common denominator, change each fraction so it has that least common denominator, and then combine them together. Whatever that least common denominator is going to stay in factored form. So if it's not factored at the beginning, we're going to factor it out. We're going to see all the individual terms, and then we'll combine them together to get the least common denominator, okay? So they'll look like this, and they'll start easy, that 1/2 plus 1/3. Obviously not the same denominators, right? What's the least common denominator of 2 and 3? 6. So I got to change this to be over 6, and I got to change this to be over 6. This would be times 3. This would be times 2. And I'd get 3/6 plus 2/6 or 5/6. So when we're adding, we're not changing the denominator, right? We keep the denominator as it is once we find them to both be the same. Now we get into ones like 3. So we've got an expression in the bottom. But are they the same? Yes, so still pretty easy. All I have to do is combine them. So I just have to do 1 plus 2, whatever the sign is, right, which is 3 over x plus 1. Stays just like that. Can't simplify it. It would be the same for 2, would be like 1. I have to change them to be least common denominators. 4 is almost the same as 3, except this is a minus, right? So this minus changes the signs of both of these. Just be really careful. So when I combine that, it's going to stay as x plus 2 in the bottom, but my numerator is going to be x plus 1 minus 2x minus 3, which means these both get the minus. So x plus 1 minus 2x plus 3, all over x plus 2, or negative x plus 4 over x plus 2. And that cannot be simplified. So I can't do the 2 into the 4, and I can't cancel out the x's because remember it's an expression that has that plus or minus between it, so you can't break it apart. Poor kid, just watch the video. Good so far? Yes? All right, number 2, you want to change this so it has 12 as its denominator. That becomes 2/12 plus 1/12, or 3/12, and that gets reduced to be 1/4. Okay, so then they just get a little bit more complex. All right, something like number 5. That's not really more complex, but it's not an addition or subtraction, right? So what's the least common denominator for x and 6x? 6x. So I want to change, I don't need to change the one on the right, that's going to stay the same, but I want to change this by multiplying both the top and the bottom by 6, so I get 6 over 6x plus 5 over 6x, and I get 11 over 6x. Yes, good question. So if you can simplify it, then you certainly can, as long as you don't cancel out both. Like you can't cancel if it was plus, right? Yeah. Okay, so now look at 7, right? These are completely different denominators. They can't factor, right? Because that's going to be a step we're going to eventually do. First thing is look at them and see if they can be factored. They can't. So these are two completely different things. It's like having an x and a y. They are not the same in any way, shape, or form. The least common denominator is the product of them. So our least common denominator is x plus 2 times x minus 4. So I need the 1 over the x plus 2 to be something over x plus 2, x minus 4. And I need the 3 over x minus 4 to be something over x plus 2, x minus 4. So whatever I multiplied in the bottom, I have to do to the top, right? So for my 1 over x plus 2, what's missing? The x minus 4. So I would have done this. You don't have to write the bottom out every time, but you do the top. 1 times x minus 4 is x minus 4. And the second one, you're missing what? The x plus 2. So I'd have to multiply the 3 times the x plus 2. That 3 is going to get applied to both. So I would distribute it and I'd get 3x plus 6. So this takes over the left one. This takes over the right one. So I'd get x minus 4 over, you don't have to write it every time. Once we get good at this, we'll combine them. Minus 3x plus 6 over the same thing, x plus 2, x minus 4. Now they have the same denominator, so I can combine them into 1, but don't forget this minus goes to both. So I get x minus 4 minus 3x minus 6 over x plus 2, x minus 4. I'm going to combine my like terms in the numerator. 1x and negative 3x is negative 2x. Negative 4, negative 10, negative 6, negative 10 over x plus 2, x minus 4. Now you can take out a negative 2 on that, negative 2x plus 5, or a positive 2 and just change the signs. But it's not going to cancel with anything, so you don't have to do that step. I would take either of these answers. I would take this one, or I would take this one.
Are you allowed to multiply the x plus 2 times x minus 4?
Like actually FOIL it out?
Yeah.
It's just an extra step you don't need to do.
Okay.
Yeah, it doesn't necessarily make it wrong.
Okay. So would you allow that? Or?
Sure. You just don't need to do it. So 6, the least common denominator would be x and x plus 1. You'd have to multiply again by what's missing. 7, least common denominator would be x minus 3 and 3x minus plus 4. Again, multiply out what's missing. I'll come back to this and I'll work it out on the video, but I want to make sure we're okay so far. Okay. Finishing off this slide, 6, your denominators are x and x plus 1. So my least common denominator is both x times x plus 1. This needs the x plus 1, and this needs the x. So I'd get x plus 1, because that's what 1 times that is, plus x all over x times x plus 1. And combine my like terms in the top, 2x plus 1 over x times x plus 1. For 8, these are two different terms. So the least common denominator is the combination of them, x minus 3 and 3x plus 4. So the first one's going to get the 3x plus 4 because that's what it's missing, and the second one, x minus 3. Distribute here, and I get 3x squared plus 4x. Distribute a negative 2 here, and I get negative 2x plus 6. So the negative 2 times the negative 3 gives me positive 6 over x minus 3 and 3x plus 4. Combine your like terms, 3x squared. These two combine, positive 2x plus 6 over x minus 3 and 3x plus 4. Now let's jump to 10. So what's different with this one than was before? It's x squared minus 9, which is factorable. So I'm going to look at my denominators. I'm going to make sure it's not factorable. This time it is. I'm going to factor it. X plus 3, x minus 3. So what's my least common denominator? X plus 3 and x minus 3. You're going to list every different term that's there. So x plus 3 is different from x minus 3, right? If something was raised to the second power, then you have to do it to the highest power. So if I had x minus 3 and then x minus 3 squared, my least common denominator is x minus 3 squared. It has to be the highest power on it, okay? So this first one I don't have to change. This gets carried down 2 over x plus 3, x minus 3. The second one, I'm missing the x minus 3, so both the top and the bottom would get it. I would distribute 4x minus 12 over, and it's the same denominator, x plus 3, x minus 3. Now just add your numerators here, and I'd get 4x minus 10 over x plus 3, x minus 3. This time you can factor out a 2, but again, it's not going to cancel with the bottom, so you can leave it how it is. It would be 2x minus 5 over the same thing. Those are both right. Questions on that one? All right, so like I said, I'm going to go back and answer all the other questions that are on here. Feel free to go back after your quiz tomorrow and watch the rest of them, and then that homework will be due Thursday. Okay, but this is content that's on your test next week, but it's not on your quiz tomorrow. Yeah. I know, I got to move it. I literally just found out at lunch that we were doing this, which I was like, woohoo, but I'm going to shift it. Yeah. Okay, so gonna finish up number 9 here. So the least common denominator is the combination of these two, 2x minus 1 and x plus 2. This is gonna get the x plus 2. This is gonna get the 2x minus 1. Distribute here, x squared plus 2x, and then I'm gonna take the negative with the 1. So I'm gonna distribute a negative 1 minus 2x plus 1 over 2x minus 1, x plus 2. Combine your like terms. These are going to actually cancel out. X squared plus 1 over 2x minus 1 and x plus 2. And 11 is a factorable one. So the first two denominators don't factor, but the last one would be x plus 1 and x minus 1. So the least common denominator is that, x plus 1 and x minus 1. The first two is missing the x minus 1. The second one is missing the x plus 1. This already has everything intact, so you don't have to change that. So I'm going to distribute first the 2 here, 2x minus 2. Then distribute the 2 here. It's a positive 2, so I keep it positive. 2x plus 2. And then I keep the plus 1. All of this goes over x plus 1 and x minus 1. Combine your like terms here. 2x plus 2x is 4x. Negative 2 and positive 2 cancel out. Plus 1 over x plus 1, x minus 1. That was the last example from the P5 Part C notes. Now we get into the quiz review. This is a second review that is on your review assignment. Go ahead and get it open. So it's on the review assignment. It's at the top. I put it all the way at the top. It's a better review, so that's why we're going to do it. It doesn't mean the other one doesn't help you. The other one definitely helps you. Kiara.
Oh, I was just wondering, how many questions is there?
There's 8 questions. Yes, 8 questions. This is fun when you are almost losing your mind. 8 questions. They are mostly equal weight except for the ones that have like a division or multiplication, and there's a lot of factoring. Those are going to be worth a little bit more. Yeah. So look through this, okay? Let's work through, I'm going to pick like one or two from each area, and we'll work through them together. And then our job is to, you let me know what you need as far as it goes with this one or the one from yesterday, okay? I can do either questions on either of them. So let's just start with number 1. What would we do here? In the top, I'm going to factor out an x, and I get x squared minus 4. Then what? Good. So that becomes x minus 2, x plus 2. How about the bottom? Sorry? Perfect square trinomial. It's x minus 2 squared, or x minus 2 times x minus 2. Now what? X minus 2's cancel. Can I cancel an x plus 2 and an x minus 2? No. So this becomes x times x plus 2 over x minus 2. Let me do this one. Since this one's got the difference 2 squares, x plus y, x minus y in the top. In the bottom, there are 2 y minus x's. Can I cancel anything? Are x minus y and y minus x the same things? No, but what can we do with those? One of them gets a negative. So you can put the negative out front and make it negative x plus y over y minus x, just like that. Or you can put the negative into the top or the negative into the bottom. You just can't do it both places, okay? You cannot cancel an x plus y and an x minus y. Okay, those are two different things. But an x minus y and a y minus x are opposites, so we can cancel them with the negative 1. Danielle. Oh, it is. I made it a z. That's not smart. Yeah, there you go. Don't ask me why. 3, you're going to factor the top and the bottom. 4, you're going to factor the top and the bottom. 5 is a lot like 2. 6, factor the top and the bottom. Let's skip to 7. Actually, you know what? Let's skip to a multiply one, and then I'm going to give you an opportunity to work on this a little bit, and then you're going to ask me questions when you're ready, okay? Go to 8. So it's multiply, which means look in all 4 spots, top left, bottom left, top right, bottom right, and see what can be factored. What can we factor here? Well, this should be an x. That says t. That should be an x. What can be factored on that? I don't know.
X squared minus 2t minus 3.
Okay, becomes what?
It becomes x minus 3 times x plus 1.
Good. And the bottom?
It would become x minus 2 times x plus 1.
Good. And then what cancels?
The x plus 1.
The x plus 1 in the top and the bottom? The x minus 2 in the top and the bottom? Does an x minus 3 cancel with an x plus 3? No! Don't do it. X minus 3 and x plus 3. Okay, we're going to do, I'm going to wait. So you got the top. I shouldn't have erased the top then. Okay, which was what? 3x, 2x minus 1, minus 1. Okay. The bottom, so what I do with these is I just, first of all, it's 1, so it's got to be 1 or negative. Both of them have to be the same, right? So it's 1 and 1. It's the 6x squared that's wonky. It has to be negative. So now when you're playing around, this is just separated by 1, so it's not going to be 6 and 1. I know it's going to be 5 and 3. But one of them has to be negative, one of them has to be positive. So I would do like plus 3x and minus 2x. Do outer and inner and see if it works. That's a negative 2x and a positive 3x, which is a positive 1. So I know the signs are wrong. And now I can just switch the signs. So now it's minus 3x and plus 2x. You can also do the first and last on these because that might be easier. I know it's super confusing when the last term is squared and it's negative. That's when it's hard, right? So you can also just multiply first times last and do the factor by grouping on these if that's easier.
Okay.
So now from here, these are opposites, right? So the negative can go out front. On the solutions, they are distributed in. I'm okay with either way. So if I want to distribute that in to make that negative 2x plus 1, I think on the solutions it's like 1 minus 2x. That's fine. It's also fine to keep it out front. Be careful with your opposites, okay? It stings to lose points because you lose that negative. Kiara.
Would 2x minus 1 over negative 2x minus 1 be the same?
Yes, so you distribute the negative to the bottom. You said negative, say that again. Tell me what you said again. 2x minus
1
over.
negative 2x minus 1.
Yes,
So it was like flip.
it's fine.
Okay.
Yep, because you distributed that negative and it would have been in the bottom.
Yeah.
And the order doesn't matter. Yep. Okay, we okay on 5? So 5 was a little bit like 2. You had to do, my advice is with those exponents, and that's where we tend to cross through and forget things. Feel free to duplicate that so you know that there's 2 of them right away. God bless you. And then you've got your difference of 2 squares in the bottom. And again, you can distribute that negative. So it could have been x minus a over x plus a. That's the same thing. 6, you had to factor both the top and the bottom. You should have gotten 2x minus 1 and 2x plus 1 at the end. 7 had the difference of 2 squares in the top that not only broke down once but twice. So x to the 4th minus 1 becomes x squared plus 1 and x squared minus 1. And then the x squared minus 1 gets broken down into x plus 1 and x minus 1. Now the x squared plus 1s cancel in the top and the bottom, and the x plus 1 cancels in the top and the bottom. So if you only got part the way, you won't lose all the credit, but obviously the goal here is to get all the way through. Then came multiplication. So number 8, the left side, we did that one together. Number 9, difference of 2 squares in the top left, 2x plus 1, 2x minus 1 over x plus 2, x minus 2. And then the x minus 2s can cross out in the blue, and the 2x minus 1s can cross out in the pink. What's left is 2x plus 1 and x plus 2. Hi. All right, for 12, you're going to factor completely. So I'm going to multiply first times last. 3 times 5 is 15. Factors of 15 that sum to negative 8. So they got to both be negative. It'd be negative 3, negative 5. Replace that middle term with those. And factor by grouping. Take out a 3x. I get x minus 1. Take out a negative 5, x minus 1. And then it's x minus 1 and 3x minus 5. So this one's a little tricky. First of all, this one, remember that when you're for 13, that there's going to be an x and a y and an x and a y. Because there's a term at the front and a term at the end, okay? So they're both going to have x and y. Then you can do the first times last if you want, or you can do your trial and error. But for 14, this is a little bit weird because what do you have to do first? Find the greatest common factor. What's on all 3 of these terms that you can take out? X. So I can do x and then 4x squared plus 8x minus 5. Then you're looking for the factors of negative 20 that sum to 8. Yeah.
8x.
Oh, thank you. 8x, y, and 5y squared. So when we factor that out, it's going to be like this one where you've got a y at the end too. For number, I'm going to let you continue from there. For number 15, this is what? Difference of 2 squares, right? So they're not both raised to a squared, but they are both even powers, which means it's difference of 2 squares. So that's a hint for that one. Difference of 2 squares. If they're even powers and perfect squares, then that's how that works. And then the same for 16. 16 is kind of like 13. And 17, you got to do the same as we just did. Take out the GCF and then factor. So I will finish these worked out. The answer's already there, but I'll finish these worked out if you need to watch it. Okay, they'll be on the video with the lesson. But your goal is to just make sure that you're feeling confident, you're ready to go. The other piece of advice I would give you is that sometimes number 6 is easier than number 2 for you. If you get to number 2 and you are hung up on number 2 on the quiz, you are going to stop yourself. You are going to move on, keep going, and then come back to number 2. Do not allow yourself to get rattled by a question that throws you, okay? It's so easy. Like if the first question is hard, to totally knock down your confidence for the whole thing. Don't allow that to happen. If number 1's hard, move on to number 2. Keep going until you find it's easy. You can take that quiz in any order that you want. Nobody says you have to go from 1 to 8, okay? So if it means find something that's easy, start there and then work your way backwards, do it. But don't allow yourself to get stressed out by something that throws you off, okay? Find the easy stuff. They're not always going to go easy to hard. Yeah. 30 minutes. Yeah. He asked how much time. Yeah.
Can you do 24 on the homework from last night?
Yeah. All right, we're going to finish up these. So number 13, you can do the first times last here, or you could do your trial and error. If you do first times last, right, so that it's going to be 2 times negative 15, I'd get negative 30. Factors of negative 30 that sum to negative 7 are negative, or to positive 7, sorry, negative 3 and positive 10. And then when I replace the middle term with these, they're both going to get the xy. Now I would factor by grouping from the first that I can take out an x, and I get 2x minus 3y. From the second set of parentheses, I can take a 5y, and I get 2x minus 3y. So I get 2x minus 3y and x plus 5y. For 14, we took out the x and we're here, so I can do the same thing. I can multiply 4 times negative 5 and get the factors of negative 20. That sum to positive 8, which would be negative 2 and positive 10. Replace the middle term with them. So the x is still in the front. I don't want to forget about that. But I get 4x squared minus 2xy plus 10xy minus 5y squared. Group these. I can take out a 2x here, and I get 2x minus y. Take out a negative 5y. No, sorry, a positive 5y. And I get 2x minus y. So 2x minus y and 2x plus 5y. And then again, don't forget that x in the front that we took out at the beginning. 15 has x to the 4th minus 16y to the 4th. So this is the difference of two squares. This would be x squared plus 4y squared and x squared minus 4y squared. And then x squared plus 4y squared stays the same, but x squared minus 4y squared becomes x plus 2y and x minus 2y because it's also the difference of two squares. Okay, 16 p squared plus 2pq minus 24q squared. You can either mess with the factors of the first and the last, making sure the first one gets the p and the p and then the q and the q. So factors of negative 24 that sum to 2 would be positive 6 and negative 4. Or you could have done the first and the last. Just if you're doing this way, don't forget that they get the p at the front and the q at the end. And last but not least, 17, 81 u v to the 3rd plus 3 u to the 4th. You can take out a 3 u, and I end up with 27 v to the 3rd plus u to the 3rd. So then these are both perfect cubes. The cube root of this would be 3v, sorry. And the cube root of this is u. So the 3u is going to stay at the front. First parentheses, 3v, same sign, so plus u. Second one, square the 3v, so it's 9v squared. Multiply the 2 together and change the sign so it's 3vu. And then square the last term and it's u squared. And that's it for this review. Okay, so this is the easy one, right? 9x minus 1. So this one is the negative x and the positive x. Now I got to work with factors of 8 that sum to 7. It's a -7, but there's already a negative on the x, so I really just got to work with factors of +8, and I can kind of ignore the negative there because the negative's going to take care of it from the x. So I'm just working with 1 and 8 and 2 and 4. So if I do it this way, and I would do outer and inner, that would be 1x minus 8x. And I got lucky, that's the -7x. So fill in that first step with both positives because the negative's going to come from the x. And again, if first and last works better, do that because it still works. So now your x minus 1 and x plus 1 become the -1. The x plus 8 here and the x plus 8 cancel there. So I end up with the negative, the x plus 5, and the 9 in the bottom. So the negative could be out front or distributed.
Okay, thank you.
You're welcome, Kevin.
Can you do number 6?
Can you read it to me? On the one I just gave you or the one from last night?
Last one.
Okay, give me.
X to the 9 minus x to the 6 minus x to the 3rd plus 1.
Okay, it was just factor completely, right? So group this. This I could take out x to the 6th. And it's x to the 3rd minus 1. Then I could take out a -1. X to the 3rd minus 1. So x to the 3rd minus 1 comes out, and x to the 6th minus 1 gets grouped together. Now those are both perfect cubes. And the way you know a perfect cube by an exponent is it's divisible by 3. So even though 6, like this is not a perfect cube, but x times x times x times x times x times x, 1, 2, 3, that is a perfect cube, right? So for the first one, the cube root is x and 1. For this one, the cube root, so I'm going to divide by the 3, is x squared and 1. So x minus 1, x squared plus x plus 1 comes from the first one. And then x squared minus 1, x squared, no, not, yeah, x to the 4th plus x squared plus 1. This one is the difference 2 squares. So it gets factored further. I think that that's more challenging than you will see.
Okay, yeah, and it also like
So that's x minus 1 squared.
Yeah.
Then there's 1, x plus 1. Then there's this,
Okay.
x squared plus x plus 1. And then x to the 4th plus x squared plus 1.
Okay. Thank you.